Hello, my name is Shailesh. This video is one of a series of tutorials for PyNN, which is a Python software for modeling and simulating spiking neural networks. For a list of the other tutorials in this series, you can visit ebrains.eu/servers/pyn, that's PYNN. In this tutorial, I'll guide you through setting up PyNN together with the Brian2, Nest, and Neuron simulators on a Linux environment. Note that we have a dedicated version of this tutorial for other environments such as Mac OS, Windows, and eBrains Jupyter Lab. I will demonstrate the installation on a computer with Ubuntu 20.04 OS installed. The steps are likely to remain very similar for other versions of Ubuntu OS and are also not expected to vary significantly for other Linux distributions. In the latter case, you can find information on the internet about how to carry out the equivalent of the tasks demonstrated here. Also, this tutorial focuses only on Python version 3 because Python 2 is no longer supported. It is recommended to use Python version 3.6 or higher. I will be using Python 3.8.10 in this tutorial because it is the default version provided with Ubuntu 20.04.
In this tutorial, we will make use of virtual environments. This allows multiple Python projects to coexist on the same computer even when they might have different and even conflicting requirements. It helps isolate projects, thereby preventing unrequested changes in others when any one of them is updated. Let's begin by creating a directory for our project. Let's first ensure that we are in the home directory. And now we make a subdirectory named pyn_project. And then we move into this new subdirectory. Next, we create a virtual environment within this directory. Python 3 provides support for creating virtual environments. To use this, we first install the package named python3-venv. Once this is installed, we can create a new virtual environment by typing python3-m venv to indicate the name of the module we just installed, followed by the name we wish to assign to our virtual environment. Here, we have set this to pyn_env. Note that this command is Python 3 and not simply Python. This is because Ubuntu 20 by default understands only the former. Once our virtual environment is created, we will now have a subdirectory named pyn_env within our project directory, with several files and subdirectories. Let's take a look at the side packages directory. As you see here, only a limited number of basic packages have currently been installed in this virtual environment. In the steps ahead, we will install various other packages which you will be able to see here. To enter this virtual environment and thereby use its resources in isolation from other projects on your computer, we have to activate it. This is achieved by running the command source pyn_env, which is the name of our virtual environment, /bin/activate. Notice how this changes the command prompt to show the name of your virtual environment. In our case, we have named it pyn_env, and this is now reflected as a prefix to the command prompt. This confirms that we are now in our new virtual environment. Note that you would be required to run the above command every time you open a new terminal window. Check that the terminal command prompt indicates the name of your virtual environment to confirm that you have indeed activated it. Before we proceed, let us run the following commands to ensure that our environment is set up as required. Now that we have our project's virtual environment set up, we are ready to install PyNN and other simulators. In general, it is advisable to install the various simulators, especially Neuron and Nest, prior to installing Pine. For the purposes of this tutorial, we will demonstrate the installation of Brain2, Nest, and Neuron simulators. We start here with the installation of Brain2. Brain2 can be installed simply by using the pip command. Pip install Brain2. This will install Brain2 along with all its dependencies such as Cython, NumPy, and so on. We can now go back to our virtual environment's site packages directory to see how it is populated with all these packages. To confirm that we have properly installed Brain2 on our computer, we can test as follows. We open Python and we try to import the Brain2 module. If there are no error messages here and the import is successful, we have completed the installation of Brain2. You might remember that earlier in this tutorial, we had to use the term Python 3 to run Python on our system. But here, as in the rest of this tutorial, we will simply write Python. This is because once we have activated our virtual environment, for this specific environment, Python and Python 3 are equivalent. Let's now move on to the installation of the Nest simulator. Unlike Brain2, Nest is not a Python package and therefore it cannot be installed via the pip command. At the time of creating this tutorial, the latest version of Nest is version 3.1. This is currently supported by Pine version 0.10, and it is likely that other versions of Nest are potentially incompatible with this version of Pine. The installation of Nest is done by first adding the PPA repository for Nest, and then updating apt to fetch the latest package list, followed by the installation of Nest itself. This installs the Nest module along with PyNest, which is a Python interface for controlling the Nest kernel. This allows us to use Nest via Python. To confirm that we have properly installed Nest on our computer, we can try running Nest. This will display the Nest banner, which mentions the version amongst other info. Here, as we can see, we have now installed version 3.1 on our system. Next, let's verify that this is indeed accessible via Python. To test this, we open Python and we try to import the Nest module. I find that I receive a no module named Nest error when trying this right after installing Nest. But this error disappears if you log out of your system, log in again, and then try importing the Nest module. Let's give this a try. I have now logged back into my computer and opened the terminal. As before, we need to move into our project directory and activate our virtual environment. And now we once again try to import the Nest module via Python. And as expected, there are no error messages this time around. So the import is successful and we have completed installing Nest simulator and are able to load it via Python. We next move on to the third simulator, Neuron. Similar to Brain2, the installation for Neuron can be easily done via the pip command. Do note that this method of installation does not auto-enable MPI support, which would be required for running simulations in parallel. Do visit the Neuron website if you wish to install on clusters or HPC machines. To confirm that we have properly installed Neuron on our computer, we can test by running Neuron. To do this, we run Neuron via the nrniv command. This will display the Neuron banner, which mentions the version amongst other info. We can see that we have now installed Neuron version 8.0.1 on our system. Next, let's verify that we can load the Neuron simulator via Python. To verify this, we open Python and we try to import a submodule named H from the neuron module. If there are no error messages here and the import is successful, we have completed installing the neuron simulator on our system. Now that we have installed all the simulators we intend to use, we move on to installing Pine itself. Because Pine is a Python package, we can install it easily using the pip command. Pip install Pine. Note that the Pine project is spelled with the capital P, small y, and two capital N's. The pip command is case insensitive, so you may write it differently here. But the Python module, as we'll see later, is case sensitive and is spelled starting with a small p. This is in line with general Python convention whereby package names start with small letters. Let us now confirm that Pine has been successfully installed on our system and that it is indeed able to communicate with the other simulators that we installed previously. We can test this by trying to load the various simulator backends of Pine. As an example, let's open Python and import the Brian2 backend of Pine. We can run some operations such as setup and end to verify that they do not produce any errors. You shall learn more about these operations and others in the upcoming tutorials. This confirms that Pine has been properly set up and also that it is able to employ the Brian2 simulator. We can similarly verify that Pine is also able to communicate with the Nest and Neuron simulators. To do this, we simply need to replace Brian2 with Nest, and that's it. Sim now refers to the Nest backend of Pine. And we can do the same for the Neuron simulator. We replace Nest with Neuron. This confirms that all the required software packages have been successfully installed and are functioning as expected. As a last step, we will install a Python package named matplotlib that would come in handy in the tutorials ahead. Matplotlib is a popular plotting library and we shall employ this in the following tutorials to produce graphical outputs.
That is the end of this tutorial, in which I've demonstrated how to install Pine and other required simulators in a Linux system. You're now ready to start modeling. To learn about model development in Pine, take a look at our next tutorial. Do keep an eye on the EBRAINS website for all the latest tutorials on Pine. We have listed here some links that might be of interest to users who wish to find more details about the various softwares employed in this tutorial. Pine has been developed by many different people with financial support from several organizations. I'd like to mention in particular the CNRS and the European Commission through the Facets, BrainScales and Human Brain Project grants. For more information, visit neurolensemble.org/Pine. If you have questions, you can contact us through the Pine GitHub project, the Neural Ensemble forum, eBrains support, or the eBrains community.